Okay, this problem says, write the quadratic function in the form g of x equals blah, 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 and then give the vertex of its graph. Well, that's what the directions say, but I could do it in the opposite order because Alex just wants me to enter both of those in. So I could actually figure out the vertex first and then write it in the form of a times x minus a squared plus k. Because to do that first, I would have to take this equation here and do something that's called complete the square, which is frankly kind of a pain in the ass. So I'm going to do it the other way, which is kind of sneaky, but hey, I'm using a valid method. So okay, so let me get this here. All right, so what I'm going to do is I'm actually going to use this function, which is in the standard form. And the standard form is ax squared plus bx plus c equals 0. When it's in that form, the vertex actually has the ordered pairs of negative b over 2a, comma, f of negative b over 2a, which basically says from the equation, here's b and here's a, take negative b and divide it by 2a. Then take that answer and plug it into the function where the x's are and calculate g of x or f of x, whatever letter you're dealing with. And that'll give me the vertex. And then once I have my x coordinate and my y coordinate here, I'm just going to go up here and stick the x where h is and the y where k is, and I'll have it in the right form. Sneaky, huh? Okay, well, remember x is going to equal negative b over 2a. So it's negative b, here's my b, right? Or let me use a different color. Here's my b. So that's going to be the negative 8. So it's negative of negative 8 over 2 times a. And a, which is right here, would be the negative 2. So this is going to be negative 8 is positive 8 over 2 times negative 2 is negative 4, and 8 divided by negative 4 is negative 2. So my x coordinate of my vertex is negative 2, and I just need to find my y now. So I am going to take that negative 2, and I'm actually going to calculate. It was g of x equals negative 2 times x squared minus 8 times x minus 5. And I'm going to calculate g of negative 2. So I'm just sticking negative 2 everywhere in that function where there was an x. And so let's see, order of operations says do the exponent first. So negative 2 squared is positive 4. And then I'll do the multiplications next. Negative 2 times 4 is negative 8. And then right here, I've got a minus 8 times a minus 2. That's going to become a plus 16. And then I still have the minus 5. And then negative 8 plus 16, you'll do your adding and subtracting from left to right. I'm still following order of operations. Negative 8 plus 16 is 8, and 8 minus 5 is 3. So that is my vertex. And I can then put that back up here. They wanted me to write it as this. G of x is going to equal, now here's the fun part. There's an a right here. Whatever that a is, it's the same as this a right there, which was the negative 2. and then it's going to be x minus h. When it's in this form, I know earlier I wrote this is the x coordinate, this is the y coordinate. When you're in this form, this is your h and this is your k. So it's x minus h. H is a -2. And then it's plus k, and k was the 3. And the only thing I can do to make this more simplified is this minus of a -2, that becomes a +2. So let me go back to the other page here. All right. My vertex right here is going to be -2, 3. And then right in here, I'm going to type in -2 times x plus 2 squared plus 3. That's the easiest way to do that part. And then they're going to have you go to the graph. Now for this part, I'm going to pause for a second. I'm going to switch over to the Alex program and show you how to do that. Okay, so I'm back in Alex, and here's my problem, and it said write it in the form, so that's -2 parenthesis x plus 2 close the parenthesis. I need an exponent squared. Scroll back down and go plus 3. The vertex is -2, 3. And then, since I know this is a quadratic formula, which means it's a parabola, which means it's a curve, for Alex, it says finally graph the function by plotting the vertex and 4 additional points, 2 on each side of the vertex. Okay. All right, I'm going to pause again. I had to come back to this page, which is a screenshot, because I can't write on the other one. But it said it wanted the vertex and then 4 other points, 2 on each side. All right, here's my vertex right here, -2, 3. So if I plot it at -2, 3, that would be right there, okay? Which means my axis of symmetry, I'm going to do a dotted line right here. The axis of symmetry goes right through the vertex, and if you were to fold the parabola along the vertex, you'd have a perfect mirror image on each side. So I want to go, use orange. It says 4 additional points, 2 on each side of the vertex. That means I'd need 2 points over here and 2 points over there somewhere on my graph. And since I'm limited to space on here, I'm just going to go 2 to the left. So for -2, if I go 2 to the left, I'd be looking at the coordinates for -3 and -4. And if I go 2 to the right, like I'm here, this is -3, this is -4. If I go 2 to the right, I'd add -1 and 0. Does that make sense? And then I'm going to have to plug and chug them into this equation. However, the beauty of this is that whatever you get for this ordered pair at 0, since 0 is here, his mirror image is this one. They'll have the exact same y coordinate. And then for this point here and this point there, they're going to have the same y coordinate. So I really only have to plug and chug 2 points. And I'm going to go with the first two, 0 and -1. 0 is